talking about normal distributions, and that we can use a normal distribution if our data looks that way to find some locations of our data. So normal distribution looks something like this, where we have a curve that represents the frequencies of each of our data points. So something like right here, where we have a very small amount of space, very, very short, that'd be a data point that has very little frequency, so maybe it only occurs once or twice. However, here in the peak, this is where our data point occurs the most. So maybe this particular one occurs 50 times, or I'm just making up a number. But most importantly, it is the data point that occurs the most. So we call that the mode. And then, since this is a normal distribution and our graph of our frequencies is symmetrical, that means that this point right here in the middle splits the data into two even parts, very much exactly equal to each other. So this would mean that this is also the middle of our data, which is the median. And that would mean this also equals the mean. So all of these points are right there, smack dab in the middle of our frequencies. Now, what we said last time is that using this information, we can make some assumptions about our data. First of all, again, this is a 50-50 split. So 50% of our data is on this side of the mean, and 50% of our data is on the other side of the mean. So exactly equal. Now, that being the case, we can find the exact percent of data that lies in certain areas. So if we have, let's see, if we have a point here, we can calculate the amount of our data that occurs behind that point. So how much of our data is in this area. Okay? So maybe we know what this point is. Maybe it's 50. So that means our x is exactly 50, or our data point is exactly 50 in that spot. Well, this means that everything behind it is x is less than or equal to 50. Okay? Now let's put some more information in here. Maybe we know our mean, and our mean is 70 with a standard deviation of 10. So what we want to know using this information is how much of our data actually is right here. So just to lay things out a little bit more clearly, our mean is 70, and we want to find the area that represents x is less than or equal to 50. So how much of our data is less than or equal to 50? How much of it is behind 50? Do what? Oh, no. I'm saying that what we're going to be figuring out here is how much of our data is behind 50. What percent of it, in other words? Brian? Go ahead and use that. All right. So if we want to know this, what we need to find is a z-score. the z-score basically gives us a measurement of this data related to this point. So the way we calculate a z-score is we take our x, whatever this point is right here, and subtract our mean, so that we can see how far this point is from our mean. Then we divide that by the standard deviation to relate it to the rest of the curve. So yeah, we can figure out the distance from here to here, but we need to know what this curve actually looks like, and the standard deviation gives us what this curve looks like. So maybe, you know, it's a real gentle curve, not a whole lot of difference, or maybe it's an extreme curve. Again, the standard deviation is going to be able to tell us what kind of curve this is, and so it's going to take this distance and relate it to what kind of curve we have. Okay. So again, we need to find this z-score, and we do that by just plugging these numbers into our equation. So z equals x is 50 minus the mean, which is 70, divided by the standard deviation, which is 10. Now it's just a matter of doing the math. So 50 minus 70 gives us what? Negative 20, good. So now we have z equals negative 20 over 10. And negative 20 over 10 is negative 2, good. So we end up with a z-score of negative 2. Now this doesn't tell us how much data is behind, not yet. It just gives us a measurement of what this area kind of looks like. We need to do a little bit more processing with it to actually get to how much data is here. Now, I could give you that formula, but it's a formula that we don't need because we have z-tables, and that's why I've passed these out. Okay, so the first page is a table for if you have a positive z-value. And of course, a positive z-value means that we have an x that we're measuring that is greater than the mean. And that's not what we have here. Here, our x is less than the mean. And we have a negative z-value because of that. So we want to go to the second page where we have negative z-values. Okay, so we need to look up our z-value. Again, it's negative 2, exactly negative 2. The column for our first digits, and there's negative 2. Then the next digit after that would be, if this is just 2, it's point what? Yeah, if this is just 2, then to make this into a decimal, it'd be negative 2.0, yeah. So the next one we need to look for is exactly 0, which is right there. So we scroll until we get those two to match, and they end up intersecting right here at, let's see, 0.02275. Okay. So what that gives us is the probability that if we just select a data point at random from our set of data, this is the probability that that data point will fall in this area somewhere. Okay? Now, of course, we can make this into a percent by just moving this decimal twice to the right. And that gives us 2.275%. So this percent says that 2.275% of our data is in this area. Okay? Now we can use this for all sorts of real world examples, like the last one we had on Wednesday, was if we are at a light bulb factory and we know, the mean and the standard deviation for the lifespan of these light bulbs, then we can figure out the probability that a light bulb will have a particular lifespan. Okay? And in fact, what percent of those light bulbs will have a particular lifespan? Any questions? None? All right. So let's look at our z-tables real quick. I've put these images up here to help guide us to know when to use which table. So again, this one is if our x value is above the mean. This one is if our x value is below the mean. So positive and negative z-tables. But something else I want you to notice about both of these images, and that is that they are finding the area behind a particular x value. They go back here. That's not always what we want to find. Sometimes we want to find the area above it. So this would be, below this particular x value or equal to it. So like our light bulb example, what's the probability that the light bulb would have a lifespan under a certain amount of hours? That would be this right here. If we want to know the probability that a light bulb would have a lifespan of at least a certain amount of hours or greater than a certain amount of hours, then we would need above this point, not below it. But these tables both calculate for below. So the other thing that we went over on Wednesday was how to get this to not just calculate below, but also above. And it's quite easy. Again, if our frequency distribution is normal, then we can say that 50% of our data is on this side, and the other 50% is on this side. Well, what is that all together? It's 100%, right? Okay, and so that means that 100% of our data is falling in this graph. Now, as a probability, so remember we find probabilities on that z-table, turn them into percents. If we want to go from that percent to a probability, that means that the probability of our data being on this table or this graph somewhere is 1. Okay? So the entire graph altogether represents a probability of 1. Again, what we just found was this part right here. Which we said was 0.02275. Okay? But what if we don't want to know that part? We want to know the other part, the part that's above that. Okay, well, what we would need to do is take this and kind of chop it off. Literally subtract it from the entire thing. So, if we subtract this from 1, what's left over is this side. So let's go ahead and do that. So 1 minus 0.02275 is 0.97725. Okay? So again, we can calculate below, and if that's what we want, it's pretty easy. We just plug in our numbers, get our z-score, and look it up. If we want to calculate above, though, we have that extra step. We do the same thing. Plug in our numbers, get our z-score, look up the probability. But again, this probability is only going to be below. If we want above, we got to take this and subtract it from 1. Any questions? Okay. So that's what we did on Wednesday. We found out how to calculate below a point and above a point. And then I said, well, that's great, but what if we want to calculate a slightly different place? What if we want to calculate something like in between? Yeah. So we want just this area right here. Okay? Well, if we want to do that, let's think about what we know how to do. We know how to calculate below and above. So like if I take just this part right here, we know how to find that. Okay, we just calculate the z-score, find the probability, and we get that part right there. Okay? However, that's just this x value. Let's call this x1. That's just our first x value. We have another x value. Let's call it x2. Again, x2, like we've said before, if we calculate its z-score and get the probability, it's going to calculate everything behind it. So it will give us it'll give us not only this, but also the stuff that we already figured out. That's not what we want. We want to get just this part in the middle. So what we have to do is we need to figure this part out and take it away, and then figure out the part that's not behind x2 but above it and take that away to get the final answer. You're very, very close. If we did x1 from x2, then that would be, take that off of there. Actually, I wonder, could you make that work somehow? Tell you what, let's try it out, because I've never tried that. Okay. So I'm going to do it the way I know how to do first, and then let's try your way, because I want to see what happens. I think it'll be double, but let's just see. So let's get some numbers in here. There it is. Let's say that x1 is less than or equal to 65. So this one right here is 65, and when we calculate our z-score, it's going to calculate everything below it. And then x2 is less than or equal to 69. Oops, 69. So again, when we find it, less than means that it's going to calculate everything below it. Then we need a mean and standard deviation, so I'm going to say the mean is 72 with a standard deviation of 2. So we have two x values here, which means that we need to get two z-scores. So for this one, our z-score is going to be x, 65, minus the mean, 72, divided by the standard deviation, 2. This one, x2, is going to be z equals 69 minus 72 all over 2. And let's go ahead and call this z1 and z2. Okay, and again, these will both calculate below. If we want it to calculate this side, we're going to have to flip it by subtracting this from 1, right? Okay, so let's calculate these. So 65 minus 72 is negative 7. Divide that by 2 is negative 3.5. So z1 is negative 3.5. And then this one, 69 minus 72 divided by 2 is negative 1.5. Okay, so we've got our z-scores, and now we need to look up the probability for both of them. Both of them are negative, so we need our negative table. Okay, so negative table. And if we look at our table, let's see, negative 3.5. Just come down here. Yeah, there's negative 3.5, and it gives me a probability of 0.00023. Okay, and the other one, that's negative 1.5, so our probability, if we look it up on our table, is 0.06681. Now again, this one is calculating below. It's getting us this part right here. So let me label that for us. This is our P1. This one is also calculating below. It's getting this and this. It's getting all of this behind it. But we want it to calculate here. Okay? So we are going to need to not use this number, but take it and subtract it from 1 to get our new number that represents this. Okay? So 1 minus this, 0.06681. Let's see what we get. 1 minus 0.06681 is 0.93319. So this part over here, 1 minus P2, will give us this. Okay, now remember that the entire graph, the entire set of data represents a probability of 1. So if we subtract P1 and subtract P2, or 1 minus P2, it should give us just what's in the middle, right? Okay, so let's try that out. So 1 minus this first one, 0.00023, and then minus this one, 0.93319, plug that into the calculator. 1 minus 0.00023, and then minus another 0.93319 gives us an overall for this one of 0.06658. And of course, as a percent, that would be 6.658%. So just above 6.5% of our data lies right here. Make sense? Okay, well, let's try yours. So we have this one and this one. Let's subtract and see what we get. So this calculates everything back here, and this calculates this part. So if we subtract this from this, maybe we'll get this. Let's see. So 0.06681 minus this one, 0.00023. Hey, it works. Good job. So it gives us the exact same thing. You know what? I think I'm going to start using that one because that seems easier. This is just the way I've always known to do it. Yeah. I think the reason I use this one so much is because sometimes we have like multiple places that we want to calculate. And so you calculate, okay, I need to take that out, I need to take that out, I need to take that out, you know. But yeah, that works. I like that. Okay, any questions? All right. One more thing I want to show y'all. So I know that you're going to see this on Hawks at some point, and I want you to see it here before you see it on there. Excuse me. So again, normal distribution, mean in the middle, and let's say that we have an area. Okay, so we have an area, and we know that this area is equal to, let's see, 0.99224. Okay? So what we're starting off with here is not an x value, it's the opposite, it's our probability. So what we've been doing so far is we've been taking an x value, using the mean and standard deviation to find our probability. Here we've got the opposite. We've got the probability. I wonder if we could find the x value. I mean, after all, if we can find the if we can find the probability using the x, it stands to reason that we could find the x using the probability. Just work backwards, right? Okay, so first of all, I'm going to tell you this. Hawks will not give you your mean and standard deviation. And you need those to find an actual value for x. But Hawks will not give you that because what they want you to find is not a value for x, but an equation for x. So let's work through this. Again, we can find the probability using x. You know, we plug it into our z-score thing and then look it up on our chart, and that's our probability. This we need to work backwards. We're going to take our probability, look it up on our z-score chart, and plug it into our z-score formula. So let's find this first. Okay. Now this represents a really big piece of our overall graph. You know, 0.99 is a lot of our data. So we're dealing with a positive z-score. Again, it's something over the mean. So we have 0.99224, so we need to find where the 99s start. Yeah, I'm starting to see some 99s in here. Then 224 is the next digit, so 0.99202. Ah, there we go. 0.99224. So we just got to kind of look around in here and see where we find that probability. I just lost it again. Let's see. There it is. Okay, so now that we know where that is, we can look up our z-score. So the first two digits are 2.4, and then the next digit is 2. So altogether, this is 2.42. Okay? Makes sense so far? All right. Now again, we need to use our z formula to get that x. So we know what z is. We can just go ahead and put this in for that z right there. And now we need to get x by itself. In other words, solve for x. So as soon as we get x by itself, we will have something that equals x. Something that will give us x if we know the mean and standard deviation. Okay, so we need to cancel everything that is not an x on this side. Well, the first thing that I see is that we have a fraction. I'd like to get rid of that fraction. It's going to make things harder to solve if I have that fraction. So I'm going to get rid of it by multiplying by standard deviation. So if we divide by standard deviation and multiply by it, it cancels. Of course, we need to do the same thing to this side. We can't just do it to one side. So multiply by standard deviation on this side as well, which gives us 2.42 times sigma. That equals x minus mu. Okay? Well, now there's only one more thing we need to get rid of, and that's mu. Right now we have x minus mu. The opposite of that would be plus mu. Do that to both sides. Again, that cancels because they're opposites. And we have 2.42 sigma plus mu equals x. And there's our solution for x. Again, we don't know a value for it unless we know sigma and mu, so our standard deviation and our mean. But we can still get a formula that would represent it, so that if we find our standard deviation and mu, we can plug them in and get our x. Make sense? Okay. All right. So I think that's going to do it for today. Before we go, remember that next week, Wednesday, is going to be a holiday. So no classes on that Wednesday. However, I want y'all to be expecting a quiz next week. And it'd be kind of evil to give it on a Monday, so guess what day it's going to be on? Only one left. Okay? So again, expect a quiz on Monday. On Friday, hint, hint. And it's going to be going over this stuff. So know how to calculate an area behind an x value, an area in front of an x value, know how to calculate in between, and be able to give me an equation like this. Okay? But I think that will do it for today, so I will see y'all on Monday. Have a good weekend.